All right. You should have your binders open to page 8, which would be, can you taste the difference?
Yeah.
And thinking back to the day before yesterday, we were a little thrown off because of testing, but thinking back to the day before yesterday, we wrote down some information about water. And on your paper, you wrote distilled water, which is virtually, meaning that it almost clears all of the impurities, and it goes through a distillation process. So some of us have had access to this type of water if you bought it from the store. And what they do with this water is they put it in, like we went over before, they put it through a process. They boil it. When water goes from being at a high temperature, it goes from being a what to a what? A liquid to a gas. So that water vapor is then captured, and all of the stuff that was not evaporated with it is left behind, and we use that water vapor, and that's how we make distilled water. The next type of water that we sometimes have access to is our spring water. And remember, we talked about the spring water, where it's the water in the aquifer where the earth has shifted, and that pressure from the water and pressure from the earth has moved up to the top layer, and it bursts that rock, and that water springs out, which is why it's called spring water. And then most of us use this water, which is tap water. And tap water has minimum purification, which means that this is the water that goes through our municipal water treatment systems, excuse me, where it goes through the process of cleaning out any sludge and stuff that all pipes lead to the ocean, remember from Nemo? And then it goes through there, it cleans out the sludge, it comes through, then it goes to another filtration system to get out any gritty matter, then it cleans it with chlorine to clear out any bacteria that may be in the water, then it goes through the system again to try to get it as clean as it can. But again, nothing's perfect. So that's tap water. Tap water is what comes through our drains, for our showers, for our washing our dishes, washing our clothes, cooking with, drinking out of the water fountains, flushing our toilet, washing our hands. That's what tap water is, and that's what the most of us use. Any questions so far? Okay. Then now we have our observation portion, because now what we're going to do with this demonstration is we are going to see if you can actually taste the difference. Some of you only choose spring water. Some of your parents only buy distilled water, which should be from the store. Now, some of you have the filter in your home, which tries to filter it through the faucet and everything. That would be along the lines of just another step of cleaning the tap water. It's not distilled water or spring water. It's just running that tap water through another step. So it's still tap water. Some of you buy your water from the store, and those would be like the distilled water and the spring water. So you're going to be able to see if you taste the difference. Some of you just drink the water right out of the sink and right out of the tap, and it's perfectly fine with you. It's your choice. So you're going to be able to see through the three if you can tell the difference between the three. So you have a chart that looks like this. We have 3 water samples, A, B, and C. And when you get your samples, you're going to be able to first do what? Look at it. And you're going to write down what it looks like to you. If you just say it looks clear, then put just clear. Don't try to look for anything. Just look at it and see what it looks like to you. Secondly, you're going to smell it. Don't talk, though. There'll be none of this says talk or discuss. You'll smell it and write down what it smells like to you. If you say nothing, then put nothing. If you think it smells like warm summer dew, then put warm summer dew. And then the last thing you're going to do is taste it. Take a sip, drink it all. You're only going to get a swallow of it, so just drink it all. Taste it, see what it tastes like, write it down. If it tastes like nothing, then put nothing. If it tastes like something, put what you think it tastes like. Then you're going to put what you think it is. Do you think it's distilled? Do you think it's tap? Do you think it's spring? Okay? After we go through all the waters, then you're going to answer these 3 questions. You're going to put which cup you thought was distilled and why. Just a simple explanation. Then you're also going to go through your spring water and your tap water. Any questions? Okay, so 1 second. All right, now we're at the point where we're ready for the results. Are you ready?
Yes.
All right. Which one would be the worst water of them all?
All of them?
No. Not when I say worst, I mean not in taste. I mean as far as their description, which one do you think would be the worst to use for maybe like drinking? Madison. No. Like which type of water? Distilled water, spring water, or tap water? She would say tap water. Okay, so let's start with tap water first. Since you think tap water is probably the worst because it's just minimum purification, which one do you think is tap water, Jenny?
I think that sample B was tap water.
Let's see. Do you think? How many of you agree? How many of you disagree? Okay. Cup B was actually, drum roll. All right. What did you all think? Devin, what do you want to tell me? What question? Which one would you think would be the best type of water that you should actually drink, Ray?
Spring water.
Why?
Because it's purified. It's natural.
It's natural? Okay, so let me give you a little history. Back in the olden days, people thought that the ground naturally purifies the earth, purifies water, but the ground is where we have the most bacteria in the dirt. So the ground is not a natural purifier, but it is thought and believed that spring water is the best type of water, right? That's what your knowledge tells you, but when we looked at our ground, we noticed that spring water is not purified, it's just natural. So with that being said, which one did you think tasted, quote unquote, or you think was spring water? Drika.
I said
Sample A. Sample A was actually, let's see if Drika's right.
Oh,
yes.
Which lets us know that then sample C is spring. All right, now let's take a look at our next page.
You didn't explain it.
Explain what?
It says, I think, distilled water is cooked plain.
That's for us.
You're supposed to do that before we did the results. You're supposed to answer it like I think it is because it tastes this way or it looks that way. 1, 2, and 3 you're supposed to do on your own. All right, so looking at this question, did you guys get a chance to write this question down?
Yeah.
Okay. Will this information affect your choice of the type of water you're drinking or you choose in the future? Why or why not? When I ask this question, what I mean is there are some people that only buy spring water. They only choose to drink spring water. They will not drink water out of the tap. Now, let's say if that's the case and you feel like you will only drink water out of spring water, store-bought water and not tap, but for this demonstration, you were not able to tell which one was the spring water. Will that influence your decision? Since I can't even tell, will it even influence my decision? Or maybe you were able to tell and you say, well, it won't influence my decision because I still will drink only spring. Just answer that question. Take about a moment to answer it.
Well, you know, like Deer Park and
That's spring.
That's spring.
Oh, you know how limestone purifies clean water?
A little bit.
What is that? Is that known as?
That's like spring water. Because it bursts from the cap rock, which is limestone.
Say it one more time.
It bursts from the cap rock, and the cap rock is limestone.
Oh, okay.
So that's why they say it's natural, because it cleans it that way. School, tap.
Yeah, blue water.
Yeah, everything in the buildings, your schools, your churches, your homes, that's all tap water. All right, so we want to keep moving on. Raise your hand if you said that this would affect your decision from now on. Come on, tell me why.
Because my mom she buys the water with the deer on it.
This is
And-
spring.
And I didn't know it was spring water, and I didn't know it was spring water, but this spring water, it tasted nasty. The deer part, it tastes good when you put it in the refrigerator.
Okay, so maybe because of the temperature of the water. All right. I'm going to move on. So we have this information. This is just to get you being able to see that there are different types of water and maybe see if it even affects your decision on what type of water that you would drink. So now let's take a look at page 9, which is investigating groundwater and water movement through Earth's molecules or materials. Duran, every time I turn around, you do not need to write on someone else's desk. You have your own. Alrighty, so now we're on page 9, which is the page that starts off like this with this title. Everyone has it, correct?
Yes.
Okay. Now, I have the same words on my screen as you have on your paper. They may not be aligned the way that yours is, but it's still the same words and the same blanks that are on your paper. So let's take a look at some review information just so that we can move on. All right, so we know that water penetrates or breaks through the ground by the process of what? Raise your hand. Devin. Infiltration. After it infiltrates or it breaks through, we know that it then moves through the ground by the process called, if you don't know, you probably should have your binder out looking at your notes because you do have a quiz coming up next Wednesday. Nope, not capillary action. That's when it moves up through the roots. This one is it travels down through the ground. Quan. Nope, it's traveling. It's moving. That key word is moves. Percolation. Very good. So again, through the water cycle, let's just review this for a moment. When water is in the atmosphere and it gets too heavy, it falls. What is that called? Precipitation. Once it falls and it hits the ground, it can either roll off the ground back into bodies of water, which is called runoff, or it can hit the ground and break through the ground, which is called infiltration, then move through the ground, which is called percolation. Once it moves through the ground, it passes through this top layer of water, which is called the what? Water table. Once it passes through that top layer of the water table, it enters into what we call the zone of saturation. That zone also holds our what? Groundwater and our aquifer, where aquifers are located. Above there, where it actually moves through that area where it's not a lot of water because the water is just passing through. What is that zone called, Madison? Zone of aeration. Once it does that, we can get our lakes and things of that form if the water table comes too high. But if it does hit our plants and our plants use it, but it comes back through our plants and enters the atmosphere, that is then called what? Transpiration. Very good. Once it's in our lakes and the temperature rises and it comes from our lakes and enters as water vapor, that is called evaporation. Then it gets up into the air, into the clouds where it gets a little too heavy, and that's called condensation. And condensation is going from a what to a what? A liquid. A gas to a liquid. Very good. All right. So going back here, once it moves through the zone of aeration and enters past our water table into our zone of saturation, where our groundwater is located and our aquifers are stored, groundwater fills up a layer of soil or may be stored between spaces and layers of rocks. The water-filled layers are called, water-filled. Tard means slow, means not there. Aquifer. Remember, aqua means water, fer means movement, full, transferring. So we have aquifer. Groundwater makes up a large part of our fresh.
Groundwater.
Not groundwater doesn't make a large part of our groundwater. What did we just do?
Drinking water.
This makes a large part of our fresh drinking water. And more than 75% of the U.S., which is us, obtain their drinking water from groundwater. Groundwater or aquifers is fine because our aquifers are stored in our groundwater. You thought groundwater was what? It can be.
Me too.
It can be. But for this, it's one. All right. So now that we have that information, we are going to look and see how water travels through Earth's materials. There's different types of materials underground. You have sediment, you have sand, you have clay, you have just rocks that are underground. So we're going to see how it travels through and come up with some conclusions for that. So let's take a look. Before we actually look at these materials, we want to kind of put things together. We want to think of 3 examples of a liquid moving through a solid other than soil, because right now our mind is on dirt or groundwater. We want to think of other things. We're not going to talk about it. You're going to actually write it down. Think of examples that occur in your everyday life. I'll start you off with one particular example, and the one that I'm thinking of is a sponge. Now that's water. So water traveling through a sponge. Now I want you to think of other liquids traveling through solid materials. Take a moment and write down some other examples. Couple more seconds. All right, what are some things you came up with, Jenny?
Your hair.
Your hair, good. Rogerlyn?
Pipes.
Pipes, good.
Blood veins.
Yes, good. Blood going through your veins, awesome.
A cloth.
A cloth used to bathe.
Straw.
A straw, okay. Okay, we got a lot of water examples. I want other liquids. Okay, again, these are waters. What about stuff like
Pancakes. Waffle butter.
Syrup.
does that liquid have to travel through that solid?
Yeah.
For sure. What about
Cereal. Cereal.
huh? Yeah, but I'm talking about milk is a liquid. I'm talking about liquid and other materials. Okay, so we have that information down. Let's look at our next thing. Now let's link this to what we know about our science topic. Now you may need to look at your notes to help you. But what determines how fast liquids move through a solid? Take a moment, look at your notes if you don't remember. But what actually determines how fast liquids move through a solid? Duran.
How big or small the pores are.
So that means what? I need vocabulary. Aaron, permeability. Permeability is what? Devin. It's the ability to let water pass. So we know that. That's your vocabulary. We know. Now, if a liquid is able to move through the solid very quickly, then we say that it's very permeable. So if it's high permeability, I'm just writing this down so that you see it. If you have space, you can, but you also have margins on your paper because this is your notes, so that's fine if you write in the margins. That means the water travels how?
Fast.
Travels fast. That's an arrow up, high. If water is able to travel very fast, that means that that object must have a lot of what? Pores, which means it must be very porous. which means that it's high in what?
Permeability.
Porosity. Very good, Medicine. If the water does not travel very fast, it's low in permeability. So low permeability equals water travels how again? Travels slow. Which means that it's not very porous. Which means it does not have a lot of space. Again, you don't have to write it but unless you're having trouble understanding this concept, which means it's low in porosity. Now, what types of materials? We talked about two types underground. What types of material would be this one? Bryson. Aaron. But what type of soil? The soil would have to be considered a what for the water to be very porous? Starts with an A. They both do. This would have to be an aquifer. Those are the materials. The materials would have to be considered, it would be considered an aquifer. The area where water would not be able to pass through would be considered a what, Bryson? This would be an aquitard. Aquitards are not very permeable. Aquifers are very permeable. Which one would you want to dig a well? Where it's very permeable, where your water is going to be able to come. There, you don't want an aquitard. You don't want to build a well in an aquitard because you're not going to get that much water, if any at all. Any questions about this? Okay. Can I move?
No.
I'll give you a moment. We're good now?
Yeah.
Yes.
Okay. Remember, it'll be on the website. Alrighty. Now we're going to look at a demonstration. Here I have 3 containers of materials. One container will be sand, gravel, and clay. You're going to observe the materials in the 3 containers. This should actually say container. I don't have tubes, I'm using a container here. We're going to be drawing the materials in each box, then we're going to rank them 1 to 3 in order, 1 being the fastest on how we're ranking them on how we think water will travel through the materials. 1 being the fastest, 2 being the medium, and 3 being the slowest. Then we're going to predict how long it takes, whether you think it's going to take 1 second, 50 seconds, a minute, how long it's going to take for that water to pass through. Then we're going to look at the actual time, and then we're going to put down the actual rank. So, let's take a look at the materials. Now, sand, and I know that's a little bit hard for you all to see, but in looking at sand, a lot of you held sand in your hand before, correct?
Yes.
Okay. And in holding sand in your hand, you notice that they are made up of what? Little particles. You can see and you can tell all those little particles, right? So in drawing those, they are small particles. You can't see that. They are small particles, but you can see them. I'll do it in black. You see them? So you can see the particles. There's some space in between them. Sometimes it looks like you can't see the space, but you do notice that there are spaces in between the particles, correct? Even though the particles are small, it has small space, you can tell that there are individual separate particles. Sometimes it looks like it's one big particle, but especially when you hold it or you look up close, you can tell they're all separate, right? Any questions for that? Okay. Then, looking at our gravel, again, here's our sand. Looking at our gravel, those are just rocks all together. So we have larger particles with larger what in between? Spaces in between. But they're still particles all together, but we can see those particles a lot better. Correct? Okay. Yeah, if you break up the sidewalk, it will be gravel. So again, we have our sand. We have our gravel. And then our clay. This is powder clay. And when you look at clay, powder clay, it's like dust. Is it hard to pick out the little particles? Yeah, it's very hard. So this, you have those small particles, but they're almost look like one big particle together. Where it's very hard to see the individual particles. So that means it's not a lot of what in between? Space. It almost looks like it's one particle. Yes.
I thought clay had stuff that you can mold and stuff.
They do, but we're talking about powder clay. We're not talking about molding clay. So it kind of looks like it is one big particle. Looking at your particles, I want you to put your predicted rank. Do you think water is going to pass through very fast? 1, medium, 2, or very slow? 3. Take a moment and put your own rank. And then put your predicted time. How long do you think it's going to take? Do you think it's going to be 1 second, 5 seconds, a minute, an hour, half a second? Remember, it's prediction. Base your time on your rank. Yes. Okay. So now again we're going to go ahead and take a look at the different materials. What you're seeing now is the screen. It'll show up in just a little bit better in just a moment. But first, we are going to look at sand. This is the container. We're going to be watching the water drip down into the container. And on your box where it says actual time for sand, you're going to be putting your actual time that it took. Simon's going to look at the stopwatch. Simon, the blinking numbers are the seconds, and then the big number next to it is the minutes. So you just count how many seconds once I poured the water in there. Drika.
Where's the sand?
It's up in the top. Let me show you why.
Why are you
You guys don't have to get up. The sand is, sorry, I thought I had the camera on. Here's the sand in the container there. So I'm placing the sand on top of the container like so. It'll focus in just a moment. And we're going to watch the water drip down into the sand. I'm sorry, drip down through the sand. Give it a moment to autofocus. Hit one of the lights. Okay, that's good. All right, so let me get the water ready. You're going to count the seconds. Okay. There you go. He's counting. I'll wait until all the water has entered. Okay, and time? 35 seconds? 39 seconds. So in your actual time, you're going to write 39 seconds. Okay? Now we're going to look at gravel, which is our B. So we just observed sand. We're going to look at gravel. So this is our gravel. Stop it. And here's our container. And we're going to observe the water going through our gravel. Are you ready, Simon? Stop. 8 seconds. Okay. Our last one is our sand. I'm sorry, our clay. So again, we have our clay, which looks like this. And our actual time, we're going to put how much time it took. So this is our clay. Here's our container. Are you ready? Do you have a question?
Yes. After you add water to the powder clay, does it turn into clay?
Up, it's starting to drip down now. That's how you get molding. Dripping down now. Tell me when you've reached past 39 seconds. What is it at now? It says it's already at a minute and we still have water in there dripping down. So for this one here, we would put greater than 1 minute. Yep, for your clay. Actual time, yeah, not rank, I'm sorry. Sit down, bro. So this will be greater than a minute. This one was 39 seconds, the sand. The gravel was 8 seconds, and the clay was greater than a minute. So having that, now we should be able to come up with our ranks. What would sand rank as?
1,
2?
1.
2. What would gravel rank as? 1. What would clay rank as?
3.
Because the fastest is 1, the second fastest is 2, and the third fastest is 3. Any questions for that?
No.
Okay. Then now let's go to our next sheet. Here you have 3 questions. Which sample was more permeable to water? Rogerlyn. Gravel. Why is it gravel? Duran. I'm calling your name.
Oh, because the gravel is more porous,
Meaning what?
meaning that it has more space so the water
Has more space through it. Good. So the gravel provides more space. Which sample was least permeable to water? Brian. Clay. Why?
Because the water could barely
The water could barely go through it. Why did the water move faster through some materials than others? And again, you're going to give a full explanation using your vocabulary from this unit. I'm going to stop you for a second because I'm going to give you time to answer this. In addition to that, you're then going to move on to questions 4 and questions 5. This is your homework, but you have time to work on it in class. So I want you to answer, again, questions 3 and a full explanation. Make sure you're using your vocabulary. Then answer question 4 and question 5. Notice it says in a complete sentence, meaning that you must use part of
question.
the question, and it also should have some vocabulary in there. Any questions? Okay, then this concludes the lesson, and I want you working on your homework.